All right, hey everybody, welcome to the last lesson, a six-part lesson from the Science 24 chemistry unit. This lesson here is going to talk about reactions and the environment. Now, first thing that we need to talk about is fossil fuel combustion and how that affects our environment. Now, fossil fuels are energy resources from decayed remains of ancient plants and animals. Now, the energy stored must be transformed into other forms before it can be used. And combustion, or burning, as we just talked about in the previous lesson, is the most common way to transform this stored energy. So a combustion reaction. Now, this is something, again, hopefully this is a review for you. So during a combustion reaction, a fossil fuel reacts rapidly with oxygen gas. The products of the reaction are carbon dioxide, so CO2, and water. And these are on the right side of our chemical equation. This is an exothermic reaction. So again, this is review because it gives off energy. Combustion of octane, for example. So it's a component in gasoline. So if you follow along my cursor here, we have C8H12 plus oxygen gas leads us to produce carbon dioxide and water. And again, it's exothermic, so it's giving off energy. Now, you're probably saying to yourself, well, what's this 2 and this 25 and this 16 and this 18? That's because this is a balanced chemical equation. So in order to have the same amount of atoms of each element on the reactant side as I do on the product side, we had to add these large coefficient numbers in front so we'd have the same amount. The word equation for this reaction is octane plus oxygen produces, so arrow here, carbon dioxide and water vapor and energy. And you're like, well, water vapor, because we're a gas state here. So water vapor. Now, incomplete combustion. So if fossil fuels do not burn completely, they undergo incomplete combustion. And this occurs when there's not enough oxygen available. And there are 5 products of this reaction then. We have carbon monoxide, just carbon alone as a solid, then carbon dioxide, water vapor, and energy. And something that can be scary about this incomplete combustion is this carbon monoxide. It's a silent killer. It's something you can't smell and something people have to be concerned about when working in combustion reaction environments. Now, carbon monoxide, like I said, it's colorless, odorless, and it's extremely poisonous. In the body, if it combines with your blood, you'll starve the body of oxygen, causing death because the blood won't pick up oxygen anymore. It'll only pick up the carbon monoxide and not give your body the nutrients or the oxygen that it needs to sustain life. Now, greenhouse gases. So when we use gasolines for many purposes, so in our home heating, energy for other industries, driving vehicles, etc., our cars and trucks burn millions of liters of gas daily. Now, all these reactions, so these combustion reactions, release millions of tons of carbon dioxide into the atmosphere. And how does this affect our atmosphere? You're probably wondering that, and I'm sure you're excited to find out. Now, CO2 in our atmosphere. So carbon dioxide is important to life on Earth. So living creatures produce it naturally, so we breathe it out. We take in oxygen, we breathe out carbon dioxide. It's a waste product from us. Along with carbon dioxide, living creatures produce water vapor and methane gas, so CH4. These are known as greenhouse gases. Now, greenhouse gases trap heat in the Earth's surface, which is great. We want to stay warm. They also help maintain the average global temperature, which is plus 15 degrees Celsius. And without greenhouse gases, the Earth's average temperature would be about minus 18 degrees Celsius. So pretty much like the regular temperature of wintertime around here, which is not really very fun. Nope. So this leads to global climate change. Now, scientists are concerned about the current long-term trend toward global warming, meaning that we're at that average positive 15, but however, things are starting to get warmer. So along with this trend, we're seeing more and more extreme climatic events, melting glaciers, rising sea level, shifting climate zones. This past year in the winter, it was very, very warm. Now, the real threat is the rate at which climate change is occurring. This rate is much faster than it has been in the past. Now, many organisms, though, cannot quickly adapt to the fast-changing environments. So these organisms may become extinct, and some believe climate change is a natural phenomenon and that Earth and its species will just adjust, which is true, except when it really starts to speed up. So this leads us to talk about air pollution. Now, pollutants are chemicals in the air that cause harm to living things in the environment. Now, air pollutants can cause asthma, headaches, and irritation of the eyes, nose, and throat. They can also aggravate heart and lung conditions that people may have. Air pollutants combine with each other to produce acid rain. This is when rainwater has become more acid, and it leads to, it can destroy crops. It can cause rust on vehicles. It's not a great thing to have. Which further leads us to an acid-base reactions talk here. Now, an acid-base reaction is also known as a neutralization reaction, which we've talked about, where an acid and a base are the reactants, which leads to the production of a salt compound in water. An example of this is a reaction that takes place in your stomach, like we've talked about. Stomach cells release hydrochloric acid, or HCl, to help digest food. HCl is a very strong acid that can eat away at your stomach walls. Now, other stomach cells release mucus, which contains a base that neutralizes the stomach acid. Our pancreas also releases sodium bicarbonate into our small intestine to neutralize this acid, so our intestine is not eaten away. If you start to get indigestion where this stomach acid maybe starts to come back up your esophagus and such, this is where you take an antacid, which again is a base, just like sodium bicarbonate, which the pancreas releases. Now, acids and bases in the environment. So natural limestone is a base used by many industries. Limestone is a type of sedimentary rock. This base is used to neutralize lakes that have been acidified by acid precipitation. This process is called liming. So how can we reduce some of these effects of pollutants? Now, a better way to reduce them is to prevent them from forming. So example, taking sulfur from the fuel before the fuel is burned. Removing the sulfur from the fuel does a few things. Or how do we do that? When coal is burned, sulfurous emissions are produced. And so a scrubber is installed on smokestacks of many industrial plants that prevent these emissions from going into the air and producing acid precipitation. Sulfur scrubbing is a chemical and physical process that removes sulfur compounds. In the final stages, calcium oxide is injected and reacts with sulfur dioxide to form calcium sulfite, which is like a sludge. Reducing our emissions, this all reduces our emissions caused by burning fossil fuels. Next thing we want to talk about is the corrosion of iron. So corrosion is any process that chemically breaks down or degrades metal. Rusting is the corrosion of iron. So we look here in our equation, we have iron plus oxygen, because any time that you have something that's going to be broken down, you most likely need oxygen in the place, which will lead to the products of iron 3 oxide. This is a simple composition reaction. So we have one thing here, it's producing something on the other side. Rusting will weaken any iron or steel structure. And so how do we solve the problem of corrosion? There are several ways to do this. We can paint, we can galvanize, and we can have sacrificial metal. So galvanizing, this is the process of applying zinc containing molten zinc. This coats the metal with a layer of zinc which protects it. Sacrificial metal, this is using another type of metal such as magnesium that is sacrificed and rusts instead of the iron. It's commonly used metals are magnesium, zinc, and aluminum. And these are some great ways that we can protect the structures that we've built through different forms of chemistry that we talked about previously in the lesson. So I hope that gives you an idea of how chemistry is used within our environment, how it leads to the production of many useful processes and technologies and tools that we need, however, also has byproducts like pollutants that we have to be aware of. Now, how do we get around that? So thanks for listening, and I hope you enjoyed this unit.